Okay, let's get started. First up, thanks for coming. Thanks for having me. Today we're going to talk about Spring apps with AOT and GraalVM. Disclaimer, you can read that later. My name is Sam Brannen. I'm a staff software engineer at VMware. I've been developing Java for over 25 years, which might sound a bit crazy. I've been a core Spring developer and committer since 2007, and a core committer for JUnit 5 since 2015 when we started that project. So today what we want to talk about, just briefly about Spring Framework 6 and Spring Boot 3, the new generations. Then we're going to dive into AOT and GraalVM native images, talk a bit about checkpoint restore, briefly about Project Leiden, and then end with a demo. And then if you have any questions, we probably won't have time for that during the talk, so then feel free to talk to me afterwards at the apero, or maybe if we have some time after the demo, you can ask some questions then. But first up, a show of hands. Who actually programs in Java? So, a few of you, okay. Who's ever heard of Spring? Anyone? You've heard of it? All right, so some people have heard. All right, so it won't be on deaf ears completely. How about AOT? Does that term mean anything to anyone? A little bit? GraalVM native image? Anyone heard of native images? Anyone tried native images? 2 people? Okay, so it's going to be some new information. Hopefully you won't get too bored if you're not really into the Java and Spring. All right, first up, Spring Framework 6.0. That's the latest and greatest generation of the core framework for 2023, so this year and beyond. So foundational in many ways. Coming with that, some platform upgrades, baseline dependencies, Java 17 plus, but working on 18, 19, and the upcoming 20 and the upcoming 21 as well. Jakarta upgrades as well, so instead of Java EE, it's now Jakarta EE. That'll require you to upgrade to the Jakarta namespace. We have support for declarative HTTP clients. You might be familiar with Feign. If you ever use that, this is similar, but now in core Spring. And the main topic I'm going to talk about here, and the biggest effort that went into these releases was support for ahead of time optimizations, AOT, and GraalVM native image support. Now, Spring Framework 6.1, we're actively working on that right now. That's coming out later this year. There'll be support for virtual threads with Project Loom, support for Project Crack, as it's known, for JVM checkpoint and restore. There's a new REST client API that replaces or kind of supersedes the REST template. There's a new JDBC Fluent API as well that supersedes in many ways the JDBC template support. And there's a whole lot more, so it's going to be really feature packed, and I encourage you to check that out if you're into Spring. Now Spring Boot 3X, 3.0, 3.1, and 3.2. That's also a new generation, and it's based on the new generation of the core Spring framework. Has a whole lot of features, too many to mention here. Even more in 3.1 that's already been released. There was even a release today, I think 3.1.3, and 3.2 will be coming out later this year based on Spring Framework 6.1. So that also has ahead of time support and GraalVM native image support. And we'll look at that in a bit more detail. So AOT, that stands for ahead of time. A few people said they'd heard the term. Basically, instead of doing things, everything at runtime, you can do some things ahead of time during build time to make your startup of your application faster. That's the basic goal behind that. And there are many ways to achieve that. So if we look at a typical deployment for a JVM-based Spring Boot application, you would see that we have starting up the app we're developing on, or we're developing. We will compile that to JVM bytecode, right, in the build, package it up in a jar, and deploy it and run it. So we're going to have a JVM container, application jar, the JVM, a virtual machine, right, running on an operating system. So there's nothing new about that. Just want you to have that in mind and think of what could be done differently, right? So when it starts up on the container, everything's going to be, all the setup is going to happen, right? So class path scanning, looking for your components, reading all your configuration files, figuring out all the relationships between all your beans and your components. All those things, they're dynamic in nature, they happen at runtime, but you could do that in advance, a lot of that stuff. So you could process all the annotations, find all the components, and know all that kind of stuff in advance. And that's what we talk about with Spring and AOT. So what that is going to bring us, if we're using Spring AOT, that's going to reduce startup time and the memory footprint in production. In terms of interoperating with GraalVM native image, we have support for what we call runtime hints. Basically, that's the metadata that the native image compiler is going to need to know about the use of reflection, resource files in the class path, the use of serialization, the use of dynamic proxies, these kind of things. You have to inform the native image compiler that you're doing that, because otherwise those things are not permitted. And this is optional if you want to optimize your JVM deployment, but it's going to be a precondition if you want to have a GraalVM native image executable. Now the core infrastructure, that's all in the core Spring Framework, in Spring Framework 6, but the build tools are in Spring Boot 3, and there's also, obviously, as you might expect, support across the entire Spring portfolio, across many different Spring projects that provide their own AOT support and their own native image support. And last but not least, my main area of expertise, you can also test within a native image using JUnit 5 and the GraalVM native build tools. So it's nice to be able to know that you can build a native image, but you also like to be able to test it in advance to see if it actually works before you deploy. So the note here at the bottom is that AOT is in fact a trade-off with some benefits. It's an extra build step, but it also then allows for less flexibility at runtime, and the same is similar with native image. Now, if we were to use Spring AOT, here we have basically a pipeline for developing, building, and deploying an AOT optimized Spring Boot application. It's the same that we had before, but you see one new step. The second step says new there, and that's Spring AOT optimizations. So that's taking your application, and then it's going to analyze your application context, all your configuration, and it's going to generate code behind the scenes. So we use a library called Java Poet to dynamically write Java code, and that will also be compiled along with the rest of the application, the next step, and packaged up in your normal jar. And at the end, you could run it the same way you did before, but if you want to have it AOT optimized, since the AOT optimizations are in your jar, you can start your application with -d spring.aot.enabled equals true. And that will tell Spring to use the AOT optimizations, and you can benefit from that with the standard JVM deployment. Next up, GraalVM. So who knows what Graal stands for? Some German speakers here? Anyone? Any non-German speakers know what Graal stands for? No one knows? Grail, like the holy grail of virtual machines. So GraalVM native image, so we're going to talk about today. That's the de facto standard for native executables. You might have heard of GraalVM before. It also supports other things like polyglot programming on the JVM, JavaScript, Python, and stuff like that. But what we're going to focus on is the support for native image executables. So that's taking your Java code, performing static analysis and all that, and basically generating an executable that runs on the machine that you're compiling on, instead of having a JVM with bytecode interpretation and stuff like that. So this comes with some what we call closed world assumptions, and you basically can't have any runtime adaptations. So you're not really going to have a class path. You can't dynamically create classes, things like that. And now AOT process application will be used as the input, and then the output will be a native executable, and we'll see an example in the demo later on. One thing to keep in mind is that you'll have a very long build time with this to actually generate the native code. So you won't be doing this all the time. It won't be a part of your natural software development lifecycle. You won't be doing it, every 5 minutes. Maybe do it a few times a day, or maybe you have it as part of your CI pipeline. So it's definitely a different mode of deployment, different way of thinking, but you get very strong benefits and then some limitations. Now, GraalVM has support for building an application, but that's just like a command line application, right? You also want to be able to integrate that into your build. So for that, there's the GraalVM Native Build Tools project on GitHub. You can check it out. There's lots of documentation there. That's basically been a collaboration over the past couple of years between Oracle Labs, which is also here in Zurich. The Spring team, and then more recently the Micronaut team has also joined as well. So we've collaborated there to make it easy to build a native image with your build tools of choice, so Maven and Gradle, and also to run tests within a native image using the JUnit platform. So the end goal would be to be able to scale to 0 with Spring Boot native executables. And if you're here at this mini conference, at this meetup, that's probably the kind of things you're interested in for cloud deployments, right? Scaling to 0, saving on your cloud infrastructure. Some of the benefits here, just a quick overview. You're basically going to have instant startup of the native image, no warm-up, low resource usage. You'll even have a reduced service attack, so that might not be clear unless you really think about it. But since a native image is this closed world, you can't by default have serialization unless you say you want it. You can't by default, you can't create classes and stuff like that on the fly. So lots of things that could happen dynamically in a Java application that could end up being dangerous aren't even permitted unless you explicitly say that you want that to happen. Another thing about the native image I didn't mention before, so with this static analysis, the native image compiler is going to do something basically called reachability analysis to see which code in the JVM in your application and all the libraries is actually reachable. And only the reachable code, the code that's used, gets included in the native image. So if you have like methods and classes that are in your jars and you never use them, they're not even in the image, so no one can call them. No hacker can call that via reflection later on because they don't even exist. And you also have compact packaging, which is nice for deployments in a container for cloud native computing. So now we have a new step, the same as we had before with AOT, but now we have, after we've compiled all the bytecode, we're going to have the build process compile that to a native image. And then when we deploy, we're going to have this application executable and no JVM here, right? It's just an executable. You just run it, and you can even have a minimal operating system, so an even smaller container that you deploy to, for example, in the cloud. Now, if you've been using Spring Boot 2 and you want to upgrade and try some of this stuff out, first you'll have to migrate to Java 17, since as I said, that's the new baseline, in case you're on Java 8 or Java 11, something like that. You want to upgrade to Spring Boot 3 or 3.1. There are upgrade notes on that. There are also some tools out there that can help you with that migration and make it easier and automate a lot of that process. Then you want to ensure that the things you're using are ready for native image, that the libraries are supported, that the GraalVM reachability metadata is there. And you might have to configure some of your own runtime hints for your own application to say, I'm using these resources from the class path, or I'm using reflection here, things like that. Then you want to, of course, build it and test it, and then deploy to a native container. I'd like to talk briefly about some of the testing support, which I've been mainly responsible for implementing. So we do have first-class support for testing, integration tests for AOT, and also native image. The documentation link is listed here. Basically what's going to happen is in that build step, we have this AOT processing. There's also one for test processing. That's going to be build time detection of your Spring integration tests. We have explicit support for JUnit Jupyter, which is the programming model in JUnit 5. We have support for JUnit 4 and implicit support for things like TestNG, etc. Then we're going to actually analyze the application context that you're using in your integration tests, and those things will be refreshed and processed for AOT, and we'll generate some code behind the scenes, and I'll show you some of that later on. And then at runtime, so when you run the test in AOT mode, we also have support for doing that either standalone on the JVM or within a native image. Now, if you need to configure something that's not working out of the box, most things are working out of the box. All the core features in Spring, Core Spring and Spring Boot and a lot of the portfolio projects, those testing features have been tested. We test the testing support, right? So that should already work in AOT mode and within a native image. But if something doesn't work or something in your code doesn't work, you can configure or implement your own test runtime hints registrar and have it registered globally via an AOT factories file. You could also implement the standard runtime hints registrar that's not specific to testing and register it globally, or you can register it on a particular integration test class just by annotating the class with that import runtime hints and specifying that implementation. And last but not least, this reflective annotation and this register reflection for binding, those are standard annotations from Core Spring, but you can also use them on a test class. Now, completing the picture there, that's the Spring side, but there's also the JUnit side. So recently, a few months ago, we added 2 annotations for execution condition. In JUnit Jupyter, you have things like enabled on OS or enabled on JRE and stuff like that. And we added 2 at enabled in native image and at disabled in native image, so that you can decide which tests you know should run on a native image or may not work, and you can disable them so that your test suite doesn't fail when you run the native image tests. And as I mentioned before, there's the native build tools support from Oracle Labs and Spring and Micronaut, and that's built-in support explicitly for the JUnit platform. So as I mentioned before, it's going to have support for JUnit Jupyter built in and JUnit 4. And if someone wanted to, they could write some integration for TestNG or some other frameworks that run on the JUnit platform. Now, as I briefly hinted at before as well, the thing that ties it all together is Spring Boot has always had its own plugins, right, for Gradle and Maven. And with Spring Boot 3, those build tools have been upgraded and enhanced with support for the native build tools, and also the AOT support. So with your Spring Boot build, you can say, I want to generate the AOT code for my application or generate optimized AOT code for my tests. You can say, I want to build a native image, I want to run the native image, or I want to run the tests in a native image, etc. Now, JVM checkpoint restore. Who has heard of Project Crack? Anyone? No one? Okay, well, this is relatively new stuff. I'll just give you a brief overview. So the CRAC stands for Coordinated Restore at Checkpoint. And the documentation is here if you'd like to find that online. Basically, the idea is you want to bootstrap from a warmed up hotspot JVM image. So already jumping ahead to where your application was. You want to take a snapshot or a checkpoint, and then you want to stop it there, save an image off to disk, and then later start it from that image that has already been warmed up, right? So that's the idea there. This was originally developed by Azul for OpenJDK on Linux. You can check out the downloads there. There's support for, right now, you can download it and use it on Linux. I've heard that in the near future, or maybe distant future, there should also be support for Mac and maybe potentially Windows as well. But of course, one option would also be to run this in a container if you're running on Mac or Windows, and you can check this stuff out. So this has been adopted already by Amazon for AWS Lambda Snapshot. Maybe the AWS guys have heard of it, perhaps. And the keynote down here at the end is it's a simple approach towards an immediate JVM startup. That's the whole idea behind it. So what are the requirements? How can you make it work in your Java or Spring application? At the checkpoint time, the application will be paused. And that means you don't want to have any open network connections, no open file handles. And then at the restore point in time, you want to reestablish whatever connections you have, restart any listeners, connections to the database, connection pools, those kind of things. So it's basically saying, like, take a snapshot, store that off the disk, and then later come back, taking that image. Or you can take that image and you can start it multiple times, right, in different containers for cloud deployment. But it's already warmed up and already ready to go. So what that looks like in Spring Framework 6.1, we already have support for that. You can check it out in the milestones and the snapshots. Basically, you have your Spring Boot, for example, here, jar or container. You're going to deploy it with it and let it run for a while, and then you're going to create a checkpoint. Say, make like a snapshot at this point. It's going to be saved to disk in an image, a cracked JVM image, and then at some later point in time, you want to start it up from where it was stopped and paused, and that'll happen in just a few milliseconds. So that's the main goal for that. Now in Spring, I mentioned we already have this in 6.1 in the snapshot documentation. You can check out what we support there. Basically, we have custom checkpoints after the application startup, optionally with warm up if you decide how long you want to wait to warm up, or maybe if you want to invoke some of your REST endpoints, call some of your APIs to actually warm up the application, you'd have to then decide for yourself what warm up actually means for your application. So what happens is the application context, the Spring application context, gets this notification for the checkpoint and the restore, and it will then propagate the stop and restart signals to beans that want to participate in this, and that's all managed via the lifecycle interface. So the lifecycle interface has been around for many years in Spring, and now it is also used for this purpose to tie into checkpoint and restore. Now, if you want to have a look at that and see what that looks like, my colleague, Sebastian Deleuze, has put an example up on GitHub, and you can check it out and follow the README there to see how that works with a Spring Boot application with the crack. Now, everybody likes pictures and numbers, so it's a bit more meaningful maybe. Here we have the container start for application readiness in milliseconds. This is a Spring Boot web application on an Azure container with 1 CPU and 2 gigabytes of memory. So we see a standard Spring Boot JVM app might take about 7 seconds there. If you add in the AOT optimized support, it's going to start up faster, about 5 seconds. And if you're using JVM and Crack, you got 302 milliseconds, which is pretty fast, right? And then with native, of course, native is always going to win out on this. It's going to start up in about 87 milliseconds. But we see that each edition makes it start up faster. So AOT is going to be faster, and then Crack and native are going to be much, much faster for startup, which is nice for scale to zero and cloud deployments. If you haven't heard of Crack, you might not have heard of Project Layton either. Has anyone heard of Project Layton? Nope? Okay. So Project Layton, you can check it out on OpenJDK, documentation and discussions there. Basically, what the goal is that the OpenJDK team, engineers at Oracle, they wanted to introduce a well-defined static image inspired by GraalVM native image, obviously, and also inspired by what we've seen with the Project Crack support with the checkpoint and restore. So for example, you might be able to have a custom hotspot based runtime image for a specific application that's tuned for that. And one of the other goals of Project Layton is to take an incremental approach over the years, over many generations of OpenJDK, introducing something. One idea they have is weaker constraints, so not being as strict as it is with GraalVM native image, but gradually introducing constraints to what an application can do while simultaneously allowing more runtime flexibility. And one potential final goal would be a strict closed world constraints, just like you have with the GraalVM native image, but that's yet to be seen if it will go that far. And here the key takeaway, Spring's AOT strategy, the work we already have in place that's already working in Spring Framework 6 that we're improving now, we'll be improving over the next few years. This aligns very nicely with the same strategy that Project Layton has for the JVM. And we've also seen recently as well that Spring AOT with Crack can also be a nice solution. So originally we invented Spring AOT for use with native image, but we see that it's playing out nicely with both Project Crack and potentially with Project Layton in the future. So in summary, you've got a lot of choices, and I will actually see if there are any questions before I jump into a demo. Yes?
How you can test the Crack, like that is code correct?
That's a good question. And the question is, how can you test Crack? The restore, checkpoint restore. So you can check out that project. My colleague Sebastian has written some scripts. We also have some smoke tests in the Spring portfolio team. You can check that out and see how we're working on that. So the idea is basically shell scripts. There's nothing official yet, right? So what we're doing is we're saying, build the app and then start it, let it run for like 10 seconds or 20 seconds, and then send the signal. So the script will send the signal to make a checkpoint, and then it will wait a second or two, and then it will start up the new JVM from the image, and then we'll evoke endpoints like over HTTP, like REST endpoints, and make sure that it's still working. And that's about the best we can do right now. There's nothing else more automated. But there might be something better in the future. We'll see. Any other questions? No? Okay. Then we'll jump into demo time. And I have a demo cheat sheet. So if you're not familiar with Spring and you want to play around with it, the best place to go is start.spring.io to create a new application. Basically, you probably want to follow a getting started guide in order to do that. If you're familiar with Spring, you probably already know about that. So what I did for this demo is I went there and I said I want to have a web app with native image support. And then I also downloaded and installed GraalVM and native image support. Got that on my machine as well. And I will show you the app really quickly. It's basically a Spring Boot Hello World app. It says Spring.io because I wrote it for that conference, but the demo still works the same. So it's got basically a Hello World greeting service. It's got a simple implementation, which says hello CNC Meetup Zurich. Spring Boot application is in there. It's going to find all the components, And for the web, we have a REST controller that's using that greeting service, and it's going to answer to a GET request to /hello to return that. So we should be able to run that. For example, what is a Maven? First, I can show you that it's not working. How about that? Doesn't work. And that said that started up in, 0.644 seconds. So just to stand it up, we're running, that's working, okay. And then next up, I wanted to say you can compile it to a native image. I'm not going to do that now because it takes a long time. But what I can show you is the log output I had before. So I did it once before, it created executable. That took about a minute, and the whole build process with Maven took a minute to build that. And if I want to go actually look at that, that's in, not this one, but this one, then I can see in Target, there should be a Spring IO application. And the jar is there as well, right? So the original jar was 118 kilobytes, right? And then the Spring Boot fat jar with all of the dependencies in there, all the stuff in the embedded web server and everything, that is 18.8 megabytes. And now this native executable, Spring IO, it's 68 megabytes. And why is it so much bigger? So it has the whole JVM and all the libraries, everything in there, but it's one executable, so we don't have to deploy it with JVM or tell the user which version of the JVM, it's all in there. And now if I go run that, is it gonna start up faster than those 0.6 something, 600 milliseconds before? So Spring IO. So that started up in, yes, quite a bit faster. Anyone impressed? Does it still work? Yes, of course, it works exactly the same. So if we wanted to, another URL that's not there, right, it's not, that was not available. Okay, so that was running the native app. And now in terms of testing support, we also have that as well. Again, I'm not going to run that step because that takes a while, but we'll see, this is what it looks like, the output there. So we see that it found 4 containers, 3 tests, and it ran those, and that took a minute on my machine. So it took a little bit longer than the regular build because it's actually doing more. There's not one application context that it's processing. In this case, it has 2 unique ones, and it's also including all of the JUnit stuff as well. So that got output as well, and that's native tests, and that's 74.8 megabytes. So that's a little larger than the average, sorry, the standard application, the production application, but that's because you have all your testing support in there as well. So you have JUnit and assert J and whatever else is in there, and that's all in there. So if I want to run that, I'm not sure really why you would want to, but you can. If you want to run the tests really fast, native test, it's the compilation that takes a long time. Actually running it, oops, S. That goes pretty fast, and I guess I could time that for you, right? So I would say that's pretty fast to run all of the tests. Okay, there aren't many, there's 3. But even if you have a lot of tests, they're gonna run faster in the native image because it's not going out and finding them all. They've already all been found and everything. So those tests as well. This last command shows you how to run in AOT mode on the JVM. Let's see. Using Maven. So the first part is to process the tests for AOT optimizations, and then to actually run them. And you see this flag here. This Spring AOT enabled equals true, so that will actually run them in AOT mode, and we can run that. That shouldn't take too long. Except that failed to clean project. Why is that? Do I have something running that shouldn't be? Ah, yes, so it runs them once, generates the AOT optimization, and then runs them again. And the way we know that it ran them with AOT optimizations, we should hopefully see something in. It's a bit hard to see with this layout. Having a hard time seeing here. Anyway, it should show that there's an AOT optimizations were run for that version of it. And what I wanted to show you about the code, the AOT code, if you're interested in that. So I had run the AOT optimizations for the tests and included that as a source tree in my IDE. And we see there's a whole bunch of stuff that's been auto-generated code that was created with Java Poet. And if we're interested in what the core framework is doing, we could see that there are some mappings, for example, for each of the test classes we have. So we have 3 test classes. It happens to be that the copy of service tests and service tests actually use the same application context. So I wanted to show that they have the same infrastructure. Whereas the controller tests, they're using a separate initializer. And the code is real code. You can navigate it in your IDE. You can see that everything that you had in your tests, all the configuration, has now been converted to a functional style of configuration. So here we have an MVC test, controller tests. We run it normally, it passes, and it's basically saying use this greeting service. This is the one that's going to say hola in Spanish for hello. And the web MVC test, that's from Spring Boot. That's going to find our Spring Boot application configuration and find all the beans in that. So the beans are the greeting service and the controller, right, that it's going to find. And now if we look at the AOT optimized version, we can see it's not looking at our test class anymore. It's not scanning the class path to find the Spring Boot application. It's not scanning the class path to find the controller or the greeting service or any of that stuff. It's all been computed at build time, and it's been written dynamically to code, and you can actually set breakpoints in here and debug it if something's not working. But for example, we could see how are the bean definitions being registered, and we would see all of the beans that you normally have in application context, a lot of internal stuff in Spring, but also our particular application. So this application class, that's my Spring Boot application class. The greeting controller, it's not being found via component scanning. It's all hard-coded here into this. And the test greeting service that was in that test class, right? So I had this import test greeting service. That import has already been processed, and now it's in here all hard-coded. The names of the beans are hard-coded, and then you can track down the code and see what happens. Where is this? How is it going to call this method? And there it's going to create the bean definitions, and it's going to call the new constructor on that test greeting service. So you can actually look at this code that's been generated. I don't expect you to do that very often, but if something's not working, you can check it out. And for more advanced use cases, you can also generate your own code, and there are hooks in Core Spring for tying into that. And another thing that I want to show you, probably the last thing, if something doesn't work in the native image, so when I first made this demo, there was a bug in Spring Boot's testing support. And I wrote this these custom runtime hints. This is from Core Spring. It's in 6.0. You can register the hints. Runtime hints allow you to access a bunch of stuff like reflection, resources, serialization, proxies, JNI, things that you have to tell the native image compiler about. And we have an API in Spring that allows you to hook and do that more easily. Otherwise, you would have to do that in JSON files in the class path for your project. So we will actually generate those JSON files for you, and we have a nice API for that. So in this example, what it was telling me when it failed, it said that reflection was not supported for that particular method. And so then I said, okay, give me the hints. I need to do something with reflection. I want to register this particular type. And for that type, I want to say, please allow me to invoke declared methods dynamically via reflection within a native image. And then the test worked. Now that was fixed in Spring Boot 3.0.8, so I don't need that anymore. That's why the tests work anyway. But that's how you can influence what's going on inside a native image. Again, I mentioned there are several different ways. You can check out the documentation for more details on that. And that's basically it. So thank you for coming. I hope some of you got something out of it, especially those using Java and Spring. And if you have any questions, feel free to ask me during the app rep.